does suggest to me that they are on the road to true understanding. What that's going to do is make their behavior increasingly systematic. It does not imply that their behavior will be more trustworthy.
AI has universally excited many of the people in our community. Most people think this is a powerful general purpose technology that will have productivity benefits.
Figuring out whether the model is succeeding at your task is very hard because we don't have the measurement device. People are exuberant. They try a few cases. They forget about all the failure cases. They tweet about the positive cases. If you're just an AI practitioner and you think, I've got this powerful idea or this powerful model, I'd like to change the world with it, very often you're stuck at that point because what you needed is to begin with an actual problem that needed to be solved.
Hi, everyone. This is Randy Xu with Luohan Academy, and we're very, very lucky today to have with us Professor Christopher Potts from Stanford University, where he is professor in as well as chair of the linguistics department. He is also professor by courtesy in computer science. He is a member of the Stanford Natural Language Processing NLP group, as well as the AI research group. Chris is also the host of the Natural Language Understanding podcast series. So Chris, we are very, very fortunate to have you with us today, given all the news that's come out. I was wondering maybe we could start, given the week we're in, by asking you, what's your general impression of GPT-4? It's obviously made a lot of news. And how would you kind of compare it so far? What is your impression of the improvements in it versus GPT-3?
Oh, wonderful question, Randy, and thanks for the introduction. Yeah, it has been an interesting journey. I have a few reactions. The first is that from my perspective as a scientist, the big changes happened earlier with the launch of GPT-3, because that's the thing that caused a lot of us to start changing our research practices and rethink the kinds of problems that we were tackling and the way we were tackling them. So GPT-4 is a big step up in terms of capabilities. It does seem to be remarkable, and it does seem to be better at maintaining kind of its own dialogue state, which leads to much more fluent interactions. But the big changes happened earlier. So this, in a way, scientifically feels incremental. Although I will say that culturally, technologically, it does feel like this launch has changed things in people's minds.
Let me ask another more general question, which is, I think more than 2 years ago in 2020, you wrote a piece on your Medium that was titled, "Is it possible for language models to achieve language understanding?" And in the zeitgeist of the moment, with so many people being introduced, for the first time to these large language models that you've obviously been an expert in for a long time, I thought it was great to kind of review what you had written back then, because I guess some things don't really change. And, two particular quotes I highlighted were, your answer to that question, is it possible to achieve language understanding at the time, was, well, we don't currently have compelling reasons to think they can't, right? So, and then the other thing you said is that, obviously from a technical standpoint, they learn only from co-occurrence patterns in the stream of symbols that they're trained on. And so, a lot of our audience are economists, but even they will understand what that kind of more or less means. So I think when I read this, my kind of thinking about it, being a former programmer myself, is one thing you deal with a lot of as a programmer, in fact, you might spend more of your time dealing with them, are the corner cases, as we call them, right? The percentage of cases that don't really work out. You might end up spending most of your time on the small percentage of cases where something goes wrong. And I feel like maybe this is my non-natural language way of understanding this, is that you train on these large language models and you find that it has errors, right? And those, you can think of corner cases. And my understanding from talking to people in this field is that GPT-3 and some of these models work surprisingly well. Like there were a few kind of corner cases, and there's many reasons for that. A lot of human ingenuity went into that. But do you think that potentially they, these language models, even if they don't kind of understand language in a way a philosopher might consider them understanding language, they might just end up working really, really well?
Oh yeah, there's a bunch of things to unpack there. Maybe the easiest one is your corner cases idea. So first, I would just observe for your audience that the handling of corner cases has changed dramatically over the years in AI. It used to be that they were handled the way programmers handled them, which is that you would write a bunch of conditionals. And as you discovered these corner cases, you would handle them in some particular way. That really shifted in the era of machine learning. But still in the early years of that shift, the way you handled corner cases was by writing down some code that would create some features that would, you hoped, handle those edge cases. As we moved into this era of unsupervised learning on unstructured text and large language models as we know them now, the handling of corner cases became less strategic. Really now people just hope that the training data and the training regimes cover all of those cases. And I think what we're discovering as people launch these products is that even though the internal teams presumably worked hard to look for places where the model would fail, the public is more creative and finds more corner cases. And so they do arise. And we think of them as, the long tail of unusual inputs that lead to truly surprising and sometimes shocking outputs. And that problem persists. The one thing I will say is that we have a little bit, well, maybe significantly moved beyond the self-supervised paradigm that I was talking about in that blog post. I really had in mind models that were trained only on distributional data, but it's very clear that our best models, by and large, right now, are also trained with what's called reinforcement learning with human feedback, where humans directly express preferences about what good outputs are given some inputs and express preferences about how to rank different outputs. And that takes us way beyond self-supervision and into the classic mode of AI where most of the intelligence is in the end being expressed by humans so that we can help these models out. And the fact that that's so transformative that even small amounts of it seem to improve models significantly is really eye-opening, but it also kind of shows that it's not magic. It's not that somehow from just this raw distributional data, they induce these complex behaviors. Rather, they needed a lot of help from pretty smart humans.
Yeah, but somehow, like the combination of all those things, some human help, human ingenuity in designing, the algorithms, and then training data that also humans probably process, as you mentioned, as well as just massive amounts of data that seem to have these, once all these things are combined, I think the term you've used before is they have emergent properties, right? Yes. So they start to seem intelligent, they start to seem, and the number of, there must be a long tail of cases. We can always find some case where we trip it up, but in the practical application of it, in the day-to-day application of it, potentially these things work so well, all those combinations, that you end up having fewer of those than we would have imagined, even a few years ago, that they seem to work really, really well. And I guess the reason I want to focus on this question is, economists tend to think of economists have dealt with one thing that they call the productivity paradox over the last few decades, which is we have a lot of improvements, we think, in technology, especially when we think about day-to-day technology. We have not seen it in productivity numbers. And AI has universally excited many of the people in our community. Many of our economists might have disagreements on where exactly this leads. Is this going to cause us to lose jobs or cause inequality? There's disagreements there. But in general, most people think this is a powerful general purpose technology that will have productivity benefits. It seems to be smart enough that it will, make up for a lot of what we do, at least in terms of producing content, right? Writing, creating images.
Well, yes, I agree with you. Let me push back a little bit, though, on the idea that they're making fewer errors. I'm not so sure about that. I think that just take a simple technology that we all probably still depend on, something like detecting spam email. at this point, those models make very few errors, right? Probably compared to what these current large language models are doing, they make vanishingly few errors. We are asking a lot of our language models, and I think as a result, they're going to make lots more mistakes. The thing that comes to mind for me is just how poorly all of these public models are doing at grounding their own responses in evidence from the internet. You know, web search is kind of a solved problem, and there are ways to combine web search with the output of these models, and yet still what they constantly do is hallucinate evidence for their own claims. You know, they produce links that don't go anywhere, and they reference papers that have essentially nothing to do with the claim that they made. And these are all very serious mistakes. In fact, I would say that it's more severe that they're producing faulty evidence than when they were producing no evidence at all. Because when people see a link or see a link to a paper, they might assume without checking that that means it's grounded in some factual information, when in fact, all of those things might have been made up by the language model. I actually believe that this is a coming societal problem. Unless these public APIs really change and become more properly grounded in the web, so that at least users can check first order, is this actually in a document with a URL that I can then think about? We're going to have a real problem of false information being spread more rapidly than ever.
Yeah, I think someone once said something like, you know, a person with a little bit of information is more dangerous than a person who knows nothing, right? And maybe we can apply that to these large
And
language
especially if you combine it with this person being incredibly confident sounding and willing to answer any question that comes at them in any domain. Yes.
Yeah.
Did you want to return to your understanding question? That's also an interesting one before we talk about productivity.
Sure. Yeah, I would love to hear your insights on that.
Right. It remains a fascinating question for me. I would say that understanding is a loaded term, and you know, in the end, this might come down to something very fuzzy. But I do feel, as a researcher who thinks about linguistic meaning, that we can ask whether models have induced a semantics, which would be a true mapping from forms to something like concepts. And I think we are seeing a lot of evidence that these models are inducing a mapping from linguistic forms to concepts as we recognize them as humans. And that's fascinating, and that does suggest to me that they are on the road to true understanding. What that's going to do is make their behavior increasingly systematic. It does not imply that their behavior will be more trustworthy any more than it implies that people are going to be invariably trustworthy just because they have a semantics. You know, these are orthogonal questions, but it does mean that their behavior is going to be increasingly human understandable for us. And I think in a way that I think will benefit all of us. And I want to say that one key ingredient for this that's a shift from that blog post you mentioned is that clearly models today are trained on much more than just text. They're trained on symbol streams that have sensor information and code and metadata and you name it, right? And as a result, models are able to learn associations between the linguistic parts of their inputs and those other non-linguistic pieces that kind of might collectively express something like concepts. That's really crucial because I think text is a very strange, very partial reflection of the world we live in. But once you start to bring in all of that other information, it might be a very semantically rich space. And I think that might be part of what's unlocking the capacity of these models to be so apparently meaningful.
Yeah. Well, I mean, in the popular press, I won't call out anyone, but there's been a lot of, I think, misunderstanding about this. Including recently, there was a tweet by a senator from a state in between New York and Massachusetts. But I feel like maybe one of the reasons that's the case is because what these language models are doing with this big training, with all this reinforcement learning, everything else added onto it, is very different intuitively than how we as humans learn, right? I'm not sure if you agree with that Noam Chomsky article, op-ed that came out recently that said, well, the way humans learn is to, we may have some pre-built parameters as well, and somehow in our evolution, but in general, we take relatively small amounts of information and draw inference and patterns from it. Like that's how a baby learns to talk. Supposedly, that's how a human learns. Whereas these language models get these properties from good training on lots and lots of data, like you said, like metadata, all sorts of information that it can, statistically, once you put in all these patterns, it seems to learn, right?
Yes, although we should be careful with this argument. I could agree with everything that you say and still believe that large language models are going to acquire something like a semantics, because there are lots of hidden premises in the assumption that just because humans learn in one way, these models to achieve the same end state as humans need to learn in the same way. That's obviously faulty, and it might be the case that large language models are different enough from us that they require different kinds of learning regimes, but nobody has shown me that the end state couldn't be the same qualitatively, for example, which would mean that these models really do use language in a meaningful way. You need to fill in lots of premises to get there. For the Noam Chomsky article, that was kind of shocking to me because he picked a lot of examples that mainly involve syntax, and the slam dunk for these models is that they have absolutely learned a lot of the causal structure of the forms of our language. I mean, that's the kind of thing that they were inducing just from self-supervision on not even especially large corpora. The hard part is learning the mapping from forms to meanings and really understanding the world that we live in. And I just want to be clear, they continue to fall down at that job. It's just that I have some conviction based on experiments we've done that we're kind of on a path to them having that very rich semantics. But the syntax part that Noam Chomsky was talking about, that happened a long time ago, in relatively speaking, for AI, by which I mean like 3 years ago.
Okay. Yeah. So, okay. Now I think this is a good way to kind of segue into something I want to ask about, which you talked about in that presentation, which is here. I think you listed 4 areas where you would like to really focus on, and because I really want to focus on these areas because obviously they are very important to you and other people in the community. That also means that there are gaps. And it's kind of, I'm also obviously very curious how you think these gaps will get filled and how quickly. So I think the 4 are retrieval augmented in context learning, better benchmarks, last mile problems, right, for all the productive applications, and then explainability. I think you titled it as faithful human explanations. So I'm not sure which one you want to kind of tackle first, but clearly you think these 4 are very important areas of research.
Oh, absolutely. Yeah. The retrieval augmented one I mentioned, that's a growing societal problem. It is remarkable to me that large companies have deployed these models without having the ability to control their outputs to even be grounded in the web. Right? It doesn't need to be factual information, just documents that actually exist. And so a major challenge for the field is getting control of these models so that we could plausibly say that we have a knowledge store, our index of the web or whatever, and we have this language model, which is a language capability, and we're able to prevent the language model from going outside of its knowledge store. It should produce answers that synthesize actual information. And I think that retrieval augmentation is the kind of step 0 in that process. A lot of work needs to be done, but all these models should be properly retrieval augmented.
I mean,
for the bench, go ahead.
Oh, sorry. I was going to say, is that where, I think I read something where Sam Altman in an interview said that, he imagines a future where there's a few of these big models, but then every particular application, your company or your industry will, leverage off of that and build their own. Is that where you would potentially use retrieval augmented in context learning for? Or is that something different?
Well, I mean, I agree with that fundamental insight. I think ultimately these language models are going to be part of more complex systems that might have lots of other capabilities that are kind of modular, calculators and things like that. We should not be asking language models to do math any more than we should be asking our own mind brains to do math. Yeah. We should be asking computing devices to do that. For the retrieval augmented part, I should be careful though. So I think obviously models like, the Bing API are retrieving information from the web, even very recent information. It's just that what they're doing with it is completely chaotic. And that's what I mean by them hallucinating links and connecting to papers that have nothing to do with the output they produce. And I feel that that's worse. And so that just shows you how important it is for us to get real control over these model outputs in a setting where you're trying to meet people's information needs with web search, or really any information need. Yeah.
Okay. And then, sorry, I think I interrupted your train. You were about to move on to benchmark. So I guess my
Benchmarks, yeah.
benchmark is how important is this? Because on one hand, I'm thinking, this seems to be just a measurement thing, right?
But it's so important. My very wise PhD student, Omar Khattab, who's, a visionary when it comes to this retrieval augmented stuff, he observed recently that we moved into an era in which kind of, exploring a model is easy, right? You might just use GPT-4, but figuring out whether the model is succeeding at your task is very hard because we don't have the measurement device. And what you're seeing is because these APIs are everywhere and people are exuberant, they try a few cases, they forget about all the failure cases, they tweet about the positive cases, and then we have an impression that they can do something. Very often, I have an intuition that when we do the rigorous thing, even just testing on systematically created examples that we agreed upon ahead of time, we find that their performance is pretty middling. And that just shows you that we as a research community need to get better at building these benchmarks and better at spreading the word that these models are not invariably successful.
Well, now that you explain it like that, it sounds like, one, a very important problem. Two, I can imagine it's a very difficult problem.
Yeah, and it's incredibly difficult. You're an economist, so you know that in the end, really, this comes down to our ability to measure. If we can't measure something reliably, or if we're measuring it unreliably without thinking about it, we're distorting absolutely everything. And so I could pair the benchmark thing with just making sure that we have metrics that are meaningful. I've complained about this before. We have all these estimates of human performance for all of these benchmarks we've created, but they have essentially nothing to do with human performance. We're having people do machine tasks and then saying it's human performance. And that is also just systematically misleading. The bright part about this is we've moved into an era in which we could do evaluations that were much more meaningful and really much more at the level of whether we're, for example, helping a user with a task they want to perform and not just checking to see whether the model was better at assigning some labels than humans were.
Yeah. Yeah, no, I like that's something I had a question on, which is the problem is you're not necessarily comparing apples to apples, right? So humans at image recognition, you may get a computer very quickly to recognize most images of a dog better than a human, but a human can obviously recognize a very complex image, maybe very better, or even an abstract image, right? So I wonder how you would even try to figure out how to benchmark that.
Yeah, that's a nice case. In NLP, many of our examples are ambiguous because people just vary in their interpretations of language. So what we do now is pick some label that we call the correct label, and then we say that humans have fallen down on the job when they disagree on this point, when we actually know full well that the human disagreement is real and that the human thing to do would be to discuss and debate and come to some terms about what the right label should be. And the models we were talking about until recently had absolutely no capacity to do that. And so we were just being unfair to the humans in these tasks by and large. But notice we're moving into an era in which discussion and debate could at least seem to take place, and we could bring that into our evaluations if we wanted.
Sure. And then, so I think the third thing on your list was the kind of last mile problem. So
well, I don't want to get past explainability.
Okay.
But
sure.
we could call that the fourth. Sure. So I'm happy to talk about the last mile.
Sure. The last mile problem. I mean, I'm sure it's like very Wild West days right now, but I assume there's lots of companies being set up to work on this problem, right?
Oh yeah, and I just the metaphor here is kind of like, well, here's even more poetic. What we do with AI is get to the base camp of Everest and then perpetually claim that we are at the top.
Yeah.
Just because we got 95% of the way from sea level to base camp does not mean we scaled Mount Everest. And, for essentially every application that's going to involve humans, that last bit is incredibly difficult. That might be where all of the expertise and all the learning has to happen. And you see this time and time again, that people deploy things assuming the AI was going to take them to the top, and it doesn't even come close. And I think the issue is that it's not narrowly an AI problem anymore. For that last bit, you're talking about people and domains and interfaces and all of that other stuff that really embraces much more of humanistic aspects of this, product design, human-computer interaction, and then, of course, being grounded in whatever domain you're trying to have an impact in.
Okay.
So
do you seem to see some patterns I mean, now that we have a number of, companies being started, number of research being done at various organizations, are you starting to see a pattern for what seems to be working and what seems to be not?
The only pattern that I've noticed is that it's very hard to be technology first. If you're just an AI practitioner and you think, I've got this powerful idea or this powerful model, I'd like to change the world with it, very often you're stuck at that point, because what you needed is to begin with an actual problem that needed to be solved, and then possibly find a way that AI would help you solve it. But if you begin from your problem, you might realize that, a lot of the problem is interfaces or data or something like that, that really has almost nothing to do with the model that you chose at the start.
Okay. And then I think you want to talk more about explainability, right?
Well, just that I do feel like that is our best chance of getting control of these models, figuring out what kinds of internal mappings they've learned from forms to meanings, and just in general, more deeply understanding how they're going to behave when they're given new inputs. In a way, the problem facing everyone who's deploying this technology is that they did some behavioral tests with examples they could think of, and then they put it out in the world, and the range of examples their system encounters is much wider and more varied and more surprising, and the model in turn does surprising and sometimes shocking and awful things. And this is because no amount of behavioral testing could give you a guarantee about what was going to happen on new inputs. The best hope we have is to deeply understand how these models work internally. And that's the project of explainability. And I think it's not a panacea, but it is the thing that would give us something more like a guarantee, and also help us diagnose problems. The whole run of these things, we all care about trustworthiness and safety and bias. And it seems to me that addressing those issues depends on us being able to even characterize what the model is like. And I will say that even though it's a daunting task because these models are so complicated, it's a much easier task than, for example, trying to understand people, because with these models, we can essentially perform brain surgery on them to our heart's content and learn a lot about how they behave in counterfactual situations, and therefore learn a lot about their causal structure in a way that we could never do with another person.
Of course, yeah. It does seem like it's still very challenging. At least listening to people in this community, it does seem like that. Even the fact that these models have advanced to the extent they have within a short amount of time probably surprised people who are developing the models themselves. So I think that means like the explainability problem will probably take some time to figure out how exactly they work. Why do you think it's even surprised people in the community, like who've underestimated what the qualitatively as well as in terms of time?
Why has it been surprising?
Yeah.
I don't know. I guess that's an individual thing. It's been surprising to me to see how far you can get with essentially purely data-driven learning. I guess I did have a belief that a lot of the stuff that we know as humans about language in the world is not inducible from experience alone, and therefore needs to be built in. And I think that's still going to be true. I think there are still things that are kind of cognitive primitives that we have because of evolution and other processes. But it seems like it's much less of it than I would have anticipated.
Okay.
But I think what we're seeing is a kind of a dawning realization about just how much can be done with data-driven learning. Because again, we might have had a hunch about this for people, but people are kind of hard to study. Whereas with these models, we can see how they proceed in these abilities through their training regimes, and we can tweak their training and see how it affects their behavior and so forth and so on, and really learn a lot about this.
Okay, so going back to that explainability, how daunting of a task do you think this is? Because it does seem like you've made this point that without explainability, the practical applications, you probably want to limit the amount of practical applications. There are many that probably require you to have explainability, right?
Yeah, well, it's a very daunting task in a way that I think should be welcome to researchers. If people are feeling anxiety about what they're going to do in the era of GPT-4, I would say, work on the problems we're talking about, and you could see that part of the reason you have guaranteed job security for all of them is that there is just conceptual stuff that needs to work out. And that certainly holds for explainability. On the one hand, these are closed deterministic systems that we can study to our heart's content, as I said. On the other hand, it's very difficult to figure out what we mean when we talk about human interpretable concepts, or what it would mean to find the mapping from forms to meanings. And then once you've started to make progress on that task, you have the wide open world of thinking, okay, the model is biased. How do I address that? What does it mean to be biased? The model is not trustworthy in this domain. Okay, what does it mean to be trustworthy? Or what kinds of checks could we put in? And that's just going to be a lifelong journey for all of us. And in a way, this is exciting because now you're rooting for the models to get better, because then there's more to explain and more to understand. And you move out of the mode where you were kind of hoping that, your task like summarization was going to remain unsolved so that you could keep working on it, right? I think we're seeing that was always the kind of anti-pattern. Now, for all the problems that I mentioned, they become more exciting to the extent that models are better, because then you can just do more and have more to explain and understand and more to deploy and all of that.
But what are you, excited to be working on kind of the next couple of years, and what are you also excited that other people are working on?
Oh, well, so those 4 areas for sure. I really mean that. And the group of people that I work with, we're all heavily invested in those things: retrieval augmentation, creating benchmarks, explainability, and really making meaningful progress on actual problems that people have. That's all of those things are exciting aspects of the current moment where things have gotten so much better. In terms of predictions for the future, I just don't know. I mean, we can see that these models will play a role in search, and we can see other little industries where they're having an impact. I think you can start to get a sense for how the labor markets are going to be impacted by these models. And some of those trends look worrisome, where it's going to be a kind of increasing escalation of assumptions we have about people's capacity to do complicated things all day long. But, there might also be surprises. There might be bright spots. I'm sure there are going to be calamities coming for us. It just seems like the standard story of any kind of maybe sudden change in technological capability, where there's a lot of good and a lot of bad. And in the end, we just have to kind of grapple with it. But from the point of view of research, I think it is a kind of double-edged sword. On the one hand, researchers have to give up on a lot of the old mode they had, where they would pick a task and then they would think about a model innovation that would do a little better on the task, and that counted as a contribution. We do have to move into this more complicated mode where we're trying to explain models or deploy them. But that's endlessly exciting, because it just does mean that the research is going to have a larger impact. And fundamentally, I think that the questions have become more interesting for NLPers, not less. But the difference, the changes, do really mean things, especially to researchers who are starting out right now. But I'll just reiterate that I think this is, as always, the most incredible moment in the history of the universe to be doing this kind of research.
Okay, great. Well, thank you so much.
Sure.
Yeah, is there any area that you think we should look more into, or any
we didn't
questions
really get to touch on
the
the productivity issue is interesting, but maybe you can handle that on your own. Maybe as an economist, you have thoughts about this. Yeah.
Sure. Yeah, I think in general, the quick version is, I think everyone seems to think right now that these technologies, because they clearly see, I think it's because it's finally affected something that everyone who's a good student does, which is write, right, and generate kind of content. So it's affected the chattering class, if you will. And so I think everyone sees, they think that because this does a lot of what they do on a day-to-day basis, that this must be very, very productive. Obviously, the jury is still a little out. That was also true of many other technologies too. So we'll see how it impacts, but people are generally in agreement that this will have a big impact.
Yeah, that's interesting about the chattering classes. My response would be that the reason it's mainly an interest for them is that jobs that are kind of lower down were already automated away.
Yeah.
Like if you were in a manufacturing plant or something, then your job was at risk 20 years ago for a robot that could do it all day long with higher precision. And so what's happening now is not that we're somehow like isolated, but rather we're just feeling finally the pressure that everyone has felt elsewhere in the economy for decades.
Yeah, I you know that is a view that a lot of people do agree with. That you know, if you look at there's this economist named David Otter. There's other economists who worked on this. They generally believe that the automation in the last 40 years have automated middle income jobs, right? So at a white collar place, it could be a clerical worker. At a blue collar place, obviously, a lot of factory workers. And so you've created jobs at the bottom, you've created jobs at the top. And this now potentially will affect some people at the top. Now, at the beginning, I assume that most people assume that this makes certain people more productive. You still need a lot of human input into how to use these systems. As you said, even like prompting, is a art of it itself. But then it's possible that, like someone gave an example, this guy named, this economist named Joshua Gans, saying, well, in the future, are we going to have anyone write a press release anymore?
Yeah, but here's an example that comes to mind for me. So I think in the very near future, people whose jobs depend on just scheduling, that part of their jobs will disappear because models will just do that better. Absolutely. I mean, that we might currently live in that moment, and it's just a matter of productizing it. So those people are now going to be expected to be essentially relationship managers. And that's much harder work that many fewer people can do. The job still exists, but it's fantastically difficult now.
That is a worry. There's a scholar at Brookings, and he's a professor at UVA Darden named Anton Koronek, and he's been pushing the narrative that this is potentially going to cause a lot of people jobs. And the worry is not that tomorrow everyone loses their jobs, because if everyone loses their jobs, we all get universal basic income and everyone goes home. But what if 30% of people lose their jobs? What if 50% of people lose their jobs, or are not competitive anymore?
Yeah, that's the competitive. Yeah, that's right. Yeah. I mean, here's the case that's really interesting to think about. We have a physician shortage. And people assume we need to solve it by training more physicians, but it's easy to imagine that we solve it with technology.
Yeah, well, we'll see what the AMA obviously thinks in the short run, but these are all very interesting questions. If you want to be kept abreast of some of this, or even be involved, we would love to sometimes have your input on this.
Sure.
Great.
Thank you, Randy.
Well, thank you so much.
Bye.
Okay.